So what you see here is you have a main central ram which actually swings the keel inside its titanium cassette. The titanium cassette is actually where the canting keel cylinders attach. So the canting keel rams push the cassette with the swung cylinder or swung fin inside. So we can go from a 4.6 metre draft for going in harbour and down to our 7.1 metre draft when we're out sailing.
And at the moment we're up, aren't we?
We're up now. We're in harbour. Yeah, exactly.
So does that change? So this ram, this whole ram here, when you put the keel down, that swings forward, does it?
Yeah. So basically, the head of the fin swings forwards, and then the lower part of the fin swings aft. And then the clever bit is the bulb doesn't stay in the same position. The bulb stays horizontal. So basically, the keel moves in a format like this, and the bulb basically moves like that. And we have the two the two canting cylinders this side, which, as I say, move the keel port to starboard, and then obviously the fin with it. So we have the two central bearings, which are fore and aft, which are part of that. So what you see here is the two electric motors which drive the hydraulic system. They are both from a company called Helix in the UK, which make a lot of electric motors for motorsport. They're involved in Formula One, Formula E. So we went to them and discussed what options they had, and what you see here is two which power the pump train that provides Magic Carpet with all its hydraulic power.
What kind of, I mean, is there a way of sort of contextualising the kind of power output that they produce?
So the equivalent would be basically having two Golf GTIs in your engine room, basically.
That's one hell of a lot of power.
Yeah.
How much of a challenge was it to create these, or was this just I say just with respect, but was it an off-the-shelf item, or did it have to be adapted for this kind of environment, or?
So basically, Helix didn't have a product on their shelf that matched our requirements, but what they did have was the technology. So we just had to package the technology to match our requirements. So we worked with them on that. We gave them our power specifications, and they came up with a package that would fit our requirements. What you see here is the inverters. This turns the DC current into AC current to power the electric motors. And then what you see here in the middle is one of the clever bits of kit which came with this boat as well, which was something we stumbled across during the process, which is actually a DC to DC converter. So instead of having your Fisher Panda generator that you would on most 100-foot cruising boats to give you your hotel systems, this is able to convert the power stored in the battery and give us the ability to run the air conditioning all night and power water makers, the cooking system, whatever you may need.
I feel like I've stepped into sort of the undercarriage bay on an Airbus A380 or something, and it's just extraordinary in here. I mean, talk us through what we're looking at.
So with Caraboni, we developed this concept here, which is basically our main distribution. Everything inside this boat, hydraulically, comes through this area of the boat.
What are we looking at here with these big carbon tanks, Ed?
Yeah, so these are actually the reservoirs which store all the hydraulic oil. With these boats, often they're confused with being only offshore machines, but our criteria is very clear. We had to make a boat which could be thrown around an inshore racecourse, maximising our time everywhere. So that means maximising our manoeuvre time. Every single manoeuvre has to be looked at in a way where we can optimise its performance to win on not both line honours, but also corrected. We're always racing against the clock, Matt. So this is the electric propulsion, which we worked with Helix and Ship Motion. So with those guys, we did a lot of development work related to getting the prop design correct to match the power demands. Because once we've done the sailing system, we also had to consider this thing needs to move around. So what we did was, with the Verdier team, we received the whole CFD, which they did anyway for the performance side of the boat. We took that whole CFD and we actually gave it to Ship Motion, and they ran a wavefield analysis and gave us real power numbers. With those power numbers, they were then shared with Helix, and we developed the size required for the electric motor. So the extra work and detailing we did in the early phase actually resulted in us hitting our propulsion targets immediately. So we were able to hit our 10-knot cruising speed, and also the boat can achieve 12.1 knots at full power.
Right, that's impressive. And I mean, essentially then, are we looking at, yes, another Golf GTI sitting in the middle of the boat?
Slightly more, actually.
Oh, it could be the RS one.
Yeah, exactly. Yeah, it's a real jazzed up Golf GTI.
Right.
We looked at different options that were currently on the market, and none of them hit our weight criteria. So what we did instead was we decided to develop our own concept. Basically, what you see here is a Ox diesel engine. We then literally bolted an electric motor, like you see here, onto that engine, and then that gave us the ability to be able to deliver the boat from different regattas all over the Mediterranean, but also gave us two other fields. One, an ability to quietly charge the boat when Sir Lindsay is on his holidays with his family, when we've just gone all night powering the air conditioning system with the comfort mode, which basically you don't hear. What you see here is an insulated box. But also it gives us the ability to be able to charge the battery after a day's sailing, if required, if we haven't got the shore power needed on the dock for our shore charger, to charge the battery in 35 minutes.
Cool. Okay.
So, and this gives us a 48-hour range, which will give us 480 miles at 10 knots.
Wow.